Okay, so we're starting a new unit today. Section 9.1 is exploring rational functions using transformations. So we now are dealing with rational functions while still using our transformations that we've used in past units. We have two outcomes that we're looking at today. Extend understanding of transformations to include functions given in equation or graph form in general, including horizontal and vertical translations and horizontal and vertical stretches. And demonstrate understanding of radical and rational functions with restrictions on the domain. So when we look at our basic rational function, we still have the same things that are happening. So our A is still a vertical stretch. Our H is moving left or right. And our K is moving up or down. So when we look at example 1, we have our function equals 1 over x, and it wants us to sketch this. So when it's 1 over x, I would just do a table of values, so x over y. So if our x is 1, then 1 over 1 is going to be 1. If our x is 2, then 1 over 2. So we've got a half, 3, 1 over 3. Negative 2, we've got a negative half, and negative 3, we've got a negative 1/3. If you graph these points on our graph, then you get something that looks like this, and I just graphed this on Desmos. And you graph your points, and what we realize is we have an asymptote running right down the middle here at x equals 0, and we've got running right down here, which is y of 0. So we want to look at some characteristics. Obviously our domain, okay, can be any real number except x cannot equal 0 because of our asymptote. Our range can be any real number, but again, we have an asymptote, so y cannot equal 0. We have no x-intercepts or no y-intercepts, so we have nothing crossing the x or y. And we have two asymptotes, so we've got x equals 0 and y equals 0. So again, this is just the very basic rational function of f of x equals 1 over x. And we're going to look at how some vertical shifts and translations change this basic graph. So if we change the dimensions of the 1, and we now have 3 over x. Again, you could do a table of values to figure out what it looks like. You could also graph this on Desmos just to see how it changes. So you can see that the orange graph it looks like we've applied a stretch now. We've got this black graph, which ends up being 3 over x. If we look at that same black graph, and now we apply a translation on the bottom there, what happens is our graph actually shifts to the right 4. So we now have an asymptote at x equals 4 and a y asymptote still at 0. If we apply a translation here, then this graph moves our graph up. This means that we now have an asymptote at a y asymptote at 2 and an x asymptote still at x equals 4. So this shifts our graph up, and then this shifts our graph left or right. So let's look at another example. So it says, example number 2 says, draw a sketch of 3 of the functions. So we're going to look at a rational function. So we'll just rewrite this actually as 3 over x minus 4 plus 2. Make note of all the important characteristics of the function. So we could just do a table of values for this, or we could just plug it into a graphing calculator to see what happens. We know that this shift is going to move it up, so this is going to shift up 2. And we know that this minus 4 is going to shift right 4. So we now can graph our two asymptotes. So we know that there's going to be an asymptote at 2. So y equals 2. And we know that there's going to be an asymptote at 4. So we are going to get a rational expression that looks like this. And again, this is the example that we just looked at previously. Our domain is going to be x can be equal to any number except it cannot equal 4, because that's where our asymptote is. Our range, okay, is going to be any real number except for y equals 2, because again, we have an asymptote there. In this case, we are going to get a y-intercept and an x-intercept. This is something I would just graph on Desmos and figure out what those two intercepts are, or the easiest thing to do would be to tell us just approximately for this example. And then our asymptotes, again, are y equals 2 and x equals 4. We can look at one more example. It says graph the following function and identify any asymptotes and intercepts. So there's a few things we need to do for this question. First, I want you to find the x-intercept and the y-intercept. So if we find the x-intercept, we just need to remember that if we're finding the x-intercept, our y is 0. So if we plug in 0 for y, the whole thing by x minus 4, this is going to cross off, and then anything times 0, it's going to be x, or it's just going to be 0. So 0 equals 2x plus 2. We can subtract the 2. And we get minus 2 equals 2x, divide by 2, and we get negative 1 equals our x. And then we can find our y-intercept. So again, we're just going to put in 0 for x. So y equals 2 times 0. And 0 minus 4. This is going to be 0, this is going to be 0, so we're going to get 2 divided by a negative 4. So my y will equal negative 1 over 2. So we now have an x-intercept and we have a y-intercept. We could plot both of those points. So x is negative 1. So we can plot that point, and y equals a negative 1/2. So we can plot that point. So we got those 2 points now. And now I want to figure out where my asymptotes are. We know because there's a x minus 4 in the bottom that the negative 4 means that I'm shifting to the right 4, which means I'm going to have a horizontal asymptote at 4. So we can draw that asymptote in at x equals 4. But we also want to find out what shift is happening left or right, which we don't know. So how we need to do that is we've got y equals 2x plus 2 divided by x minus 4. And what I want to do is I want to actually cancel this x minus 4 off on the bottom in order to find my shift. So what we do is we end up adding something to the top so that I can cancel something off. Because this is a 4, if we go 2 times 4, then we can add an 8 to the top. But if we add an 8, we also need to subtract an 8. So all I've added is a minus 8 plus 8 and then plus 2 all over x minus 4. And I haven't changed the top. I've just added something and subtracted something. So basically, I'm adding the exact same thing, so it's like I'm adding 0. But what's going to happen is then we can actually cancel something out on the bottom. So we can actually take a common factor out of this 2x minus 8, which is 2, and then I got x minus 4 left, which you'll recognize as being on the bottom. And then I'm just going to simplify and add these two together. So this is going to be plus 10 over x minus 4. I'm now going to split these into two terms. So I'm going to get y equals 2x minus 4 over x minus 4 plus a 10 over x minus 4. What you'll see is that this x minus 4 actually crosses off, so I'm left with y equals 2 plus 10 over x minus 4. We know that this minus 4 gave us an asymptote at 4, and this is going to shift our graph up, so we're going to get our vertical asymptote at y equals 2. So if we just scroll back up here, we can put our new asymptote at y equals 2. We can connect the 2 points that we've already plotted. And we know that the other half is going to be found up here. So we've plotted our asymptotes and our intercepts. You could also do a table of values to figure out points that are up here just to kind of see what that graph would look like. You know that it's going to be a mirror and it's going to reflect over this line. So you know you're going to be able to kind of see what shape it's kind of going to make based on the fact that it's a rational function. But sometimes it helps to find some of those points just to graph it. So this is the end of the lesson. You can do the textbook assignments that you have already in your notes, and see you in class. Thank you.